The 40 degrees Celsius marking on a circuit breaker refers to the maximum allowable temperature rise above the ambient temperature when the breaker is carrying its rated current continuously. It is typically specified as a delta from an ambient temperature of 30 degrees Celsius. Therefore, the maximum allowable operating temperature for the breaker is 40 degrees Celsius plus 30 degrees Celsius, which equals 70 degrees Celsius. An observed temperature rise of 9 degrees Celsius to 27 degrees Celsius above ambient suggests that the breakers are operating within normal limits. A 9 degrees Celsius rise is below the allowable 40 degrees Celsius, while the 27 degrees Celsius rise is only slightly above it. Some heat generation is normal in electrical equipment due to the resistance of the conductors and the magnetic field in the breaker. Firstly, high load currents operating a breaker near its rated current for extended periods can increase temperature rise. Secondly, loose connections and poor electrical connections can increase resistance and heat generation. Thirdly, overheating conditions, ambient temperature, enclosed spaces, or heat sources nearby can contribute to higher temperatures. Since the observed temperature rise is within normal limits and there are no visible signs of damage, it is unlikely that there is an issue with the breakers or wiring. However, it is always advisable to investigate potential problems. 1. Verify the accuracy of the thermal imaging equipment and ensure proper calibration. 2. Check the load currents in the breakers to ensure they are not exceeding the rated capacity. 3. Inspect connections for any signs of corrosion, loose wires, or overheating. 4. Consider environmental factors that may be contributing to the temperature rise, such as ambient temperature or enclosed spaces. Based on the information provided, it appears that the breakers in question are operating within normal temperature ranges. There is likely no immediate need for concern, but it is prudent to monitor the situation and investigate any potential contributing factors. Circuit breakers are crucial components in electrical systems, designed to protect circuits from overcurrents and short circuits. Understanding their operating characteristics, including normal temperature rise, is essential for ensuring safety and reliability. The temperature rise in a circuit breaker is influenced by several factors, including the load current, ambient temperature, and the breaker's design and construction. A circuit breaker's rated current is the maximum current it can carry continuously without exceeding its temperature limits. Exceeding this rating can lead to overheating, which can damage the breaker and potentially cause a fire. The 40 degrees Celsius marking on a circuit breaker indicates the maximum allowable temperature rise above the ambient temperature when the breaker is carrying its rated current. This marking is typically specified as a delta from an ambient temperature of 30 degrees Celsius. Therefore, the maximum allowable operating temperature for the breaker is 40 degrees Celsius plus 30 degrees Celsius, which equals 70 degrees Celsius. The ambient temperature is the temperature of the air surrounding the circuit breaker. This temperature can vary depending on the location of the breaker, the time of year, and the presence of other heat sources. When evaluating the temperature rise of a circuit breaker, it's important to consider the ambient temperature to determine whether the breaker is operating within its safe limits. The observed temperature rise of a circuit breaker is the difference between its actual operating temperature and the ambient temperature. This measurement can be obtained using a thermal imaging camera or a temperature probe. If the observed temperature rise exceeds the allowable limit, it indicates that the breaker is overheating and may need to be replaced. Several factors can contribute to the temperature rise in a circuit breaker. Firstly, high load currents can cause the breaker to overheat. When a breaker is carrying a current close to its rated capacity, it generates more heat due to the resistance of its internal components. Secondly, these connections can also cause overheating. Poor electrical connections increase resistance and heat generation. Thirdly, environmental factors such as high ambient temperatures, enclosed spaces, and nearby heat sources can contribute to higher temperatures in circuit breakers. Troubleshooting temperature rise issues in circuit breakers involve several steps. 1. Verifying the accuracy of thermal imaging equipment is essential. Ensure proper calibration to obtain reliable readings. 2. Check the load currents on the breakers to ensure they are not exceeding the rated capacity. 3. Inspect connections for any signs of corrosion, loose wires, or overheating. 4. Consider environmental factors that may be contributing to the temperature rise, such as ambient temperature or enclosed spaces. The NEC, or National Electrical Code, provides guidelines for the installation and operation of electrical equipment, including circuit breakers. It specifies requirements for conductor sizing, overcurrent protection, and ambient temperature correction factors. Adhering to the NEC helps ensure the safe and reliable operation of electrical systems. Continuous load refers to a load that is expected to operate for 3 hours or more at a time. Circuit breakers that supply continuous loads must be derated to prevent overheating. The NEC specifies that circuit breakers supplying continuous load shall be rated no less than 125% of the continuous load. This derity accounts for the additional heat generated by continuous operation. Thermal imaging is a non-destructive testing technique that uses infrared cameras to detect temperature differences in electrical equipment. It can be used to identify hotspots in circuit breakers, which may indicate loose connections, overloaded circuits, or other problems. Thermal imaging surveys can help prevent equipment failures and improve electrical safety. Inspecting connections for signs of corrosion, loose wires, or overheating is crucial for maintaining the integrity of electrical systems. Corrosion can increase resistance and heat generation, leading to premature equipment failure. Loose wires can also cause arcing and overheating, which can create a fire hazard. Overheating is a sign of excessive current flow or poor connections. Investigating potential contributing factors to temperature rise includes assessing environmental conditions such as ambient temperature and enclosed spaces. High ambient temperatures can reduce the current carrying capacity of circuit breakers. Enclosed spaces can trap heat and further increase the temperature of electrical equipment. Understanding the normal temperature ranges of circuit breakers and addressing potential contributing factors can help prevent overheating and ensure the safe and reliable operation of electrical systems. In summary, the 40 degrees Celsius marking on a circuit breaker indicates the maximum allowable temperature rise above ambient when the breaker is carrying its rated current continuously. Factors contributing to temperature rise include high load currents, loose connections, and environmental conditions. Troubleshooting temperature rise issues involves verifying thermal imaging equipment accuracy, checking load currents, inspecting connections, and considering environmental factors. It's important to remember that some heat generation is normal in electrical equipment due to the resistance of the conductors and the magnetic field in the breaker. However, if the observed temperature rise exceeds the allowable limit, it indicates a potential problem that should be investigated. Monitoring the temperature of circuit breakers is an essential part of preventive maintenance. Regular inspections can help identify potential problems before they lead to equipment failures or safety hazards. By understanding the factors that affect temperature rise and implementing appropriate troubleshooting measures, one can ensure the safe and reliable operation of electrical systems. Always consult with a qualified electrician or electrical engineer when dealing with electrical issues. They can provide expert guidance and ensure that all work is performed safely and in accordance with applicable codes and standards. In addition to the factors already discussed, other potential causes of temperature rise in circuit breakers include improper installation, defective breakers, and harmonic currents. Improper installation can create stress on the breaker's internal components, leading to overheating. Defective breakers may have internal flaws that cause them to generate excessive heat. Harmonic currents are caused by nonlinear loads, such as electronic devices, and can increase the temperature of circuit breakers. To mitigate the risk of overheating, it's important to ensure that circuit breakers are properly installed, regularly inspected, and replaced when necessary. It's also important to use high-quality breakers that are designed to withstand the expected load currents and environmental conditions. In addition to monitoring the temperature of circuit breakers, it's also important to monitor the temperature of other electrical components such as conductors, transformers, and motors. Overheating in any of these components can indicate a potential problem that should be addressed promptly. When performing thermal imaging surveys, it's important to use a high-quality camera with appropriate resolution and sensitivity. It's also important to have a thorough understanding of the equipment being inspected and the factors that can affect its temperature. The results of thermal imaging surveys should be carefully documented and analyzed to identify potential problems and prioritize corrective actions. In conclusion, understanding the normal temperature rise in circuit breakers and implementing appropriate preventive maintenance measures is essential for ensuring the safe and reliable operation of electrical systems. By monitoring the temperature of circuit breakers and other electrical components, identifying potential problems early, and taking corrective actions promptly, one can prevent equipment failures, reduce downtime, and improve electrical safety. Remember that working with electricity can be dangerous. Always follow safe work practices and consult with a qualified electrician or electrical engineer when dealing with electrical issues.